Okay, this video has us solving a trig equation where the ratio turns out to be negative, and one thing that we could do at the start here is just have a look at the graph of this situation. So using a graphing package like Desmos, we can create the graph of y equals 11 sine x plus 5. That's the left hand side of this equation, and we are interested in when this graph is equal to 3. So in other words, we're looking at when does the sine graph here, the green one, meet the horizontal line that has equation y equals 3. Now you can see that there's an intersection just to the left of the y-axis here. This would be a negative x value, but it's not going to be one of our solutions because we've got a restriction on our domain here for x. X needs to be between 0 and 360 degrees. So following on through the graph, we see that they meet again here just beyond 180 degrees. So we're going to have a solution just a little bit bigger than 180, and then they meet again just short of 360 degrees. If you were to continue on this sine graph, you would find that the lines would meet infinitely, just continue on an infinite number of solutions. That's why we have a restriction on this domain. We're looking for our answers between 0 and 360. Now, it's probably worth pointing out that the distance from 180 to this point of intersection here is exactly the same distance as from the point of intersection up to 360 degrees. That's quite a small little value, and that's what I will call our first quadrant angle, but you'll see that in just a moment. So back to the equation here. The first step to solve it would be to start trying to rearrange for sine x. So subtracting 5 from both sides gives us 11 sine x is equal to negative 2, and then dividing both sides by 11 gives us sine x is equal to negative 2 11ths. And at this point you should notice that we've got this negative ratio, and that we will need to take a slightly different approach when it comes to solving this, and that approach involves the first quadrant angle that I mentioned earlier on. So what's needed here is for us to find out the size of that first quadrant angle, sometimes called an associated acute angle or an equivalent acute angle, and it's found by taking the inverse sine of not negative 2 11ths, but positive 2 11ths, and the inverse sine of positive 2 11ths turns out to be 10.475, and that number carries on with its decimal places. That's not one of our solutions. To find our solution, we need to again look to our 4-quadrant diagram, and this is how we sort of taken into account the negative here, because we're looking for the quadrants where sine, in this case it's a sine equation involving sine, we're looking for the quadrants where sine is negative, and sine is negative in the tan and cosine quadrants, the third and fourth quadrants. And to get our solutions from there, we will add 180 to this first quadrant angle, and that will give us this value here. 180 plus that 10.4 will give us this value here, and also subtract our first quadrant angle from 360. So that will give us x values of 190.457 ... I haven't rounded it yet, and also 349.524, just show that that's not rounded yet. And on the final line we'll take the opportunity to round it. I think 1 decimal place is probably appropriate here. So 190.5 degrees, don't forget the degrees there, and 349.5 degrees. So we can return to the graph and see if those values make sense. Just a little bit beyond 180, we find we've got a solution of 190.5, which is what we expected. The y part of that coordinate is 3, and again that's what we expected because we wanted to know when that graph was equal to 3, and then that second solution up there, 349.5, which matches the one that we got.